Okay, folks, welcome back. This is lesson 6 in our quadratic series. This one will talk about the last way that we can use to, solve a quadratic formula. And this will be, or sorry, I should say solve a quadratic equation. And the way we can do it is by using the quadratic formula. So just a quick review of all the things that we've done so far. Well, let's take a look at how we can solve each of these that you see on the screen here using the methods we saw in the past. So again, as usual, all the links will be provided underneath, full answer key if you want to try any of these on your own, and the solutions to check and see how you did. So if we just look at the first one here, we're really asked to use that sum and product method, and really it's that factoring piece that will just keep coming back again and again and again. So if I try to factor this, well, I can recognize that each of the terms in that polynomial each have a common factor of 2. So I can rewrite this as 2x squared plus 6x minus 7 is equal to 0. And with that trinomial on the inside of that set of brackets, this is where I can use that sum and product method. So I'm really going to look for two integers that multiply to give me negative 7, but add to 6, right, my number in the middle. So this is how that sum and product method tends to work. And I can recognize that, well, 7 and 1 will multiply to 7, and they will also add to 6, provided that my 1 is negative. And conveniently, that solves both of my problems. Right, both of those integers have to do two things, multiply to minus 7 and add to 6, so it does do that. So when I factor this, I actually get the shortcut, and I can do x and then one of my integers, so plus 7, and the other integer is negative 1, so the factor is x minus 1. And in solving these, well, I'm really looking for the value that makes each of these sets of brackets 0. So really it's x plus 7 equal to 0 I'm trying to solve, and x minus 1 equal to 0 is the other one. So I know x could either be negative 7, or x could be, well, just 1. So I've got two solutions here, and I found them by factoring. For b, I could do this as well, but I can't really use a common factor anymore. So this is where we saw that decomposition method come into play. And well, if I try to figure out what I multiply to, what I add to, I really am just going to take my coefficient of my square term and my constant, and those get multiplied together. So I need to multiply to 16. But I need to also add to 8, and the two numbers that can do that are a 4 and a 4 for me. So I can do this using decomposition by rewriting that middle term as, well, the sum of these two integers that we just found together. So I'm going to write that positive 8x as 4x plus 4x, because that will give me the 8x's in total that I need. But we've just decomposed it into its two parts to be able to factor this. So we'll take the first two terms and take a common factor from them. So 4x is common. So I'll be left with 4x plus 1. And what you'll notice, the last two terms are already the same thing. So I've got two distinct groups here, right? The 4x and the 4x plus 1. Those are multiplied together. And I'm adding to it another factor of, well, 4x plus 1. So the common factor is in my brackets, so really I've got 4x plus 1 from the brackets, and another 4x plus 1 from the coefficients of those brackets. Okay, and what I know is that, let's make this blue. I didn't do that very well. Sorry, let me rewrite this. What I know is that now those factors are the same, so really I'm just trying to solve one of them. So 4x plus 1 is equal to 0. Meaning that 4x should be negative 1, which leaves me with the solution of x is equal to negative 1 over 4 by dividing that coefficient on both sides. And I don't need to do this again for the red one because they're the same expression. So I know this only has one solution, and it's negative 1/4. Okay, so I can do this relatively close to the same way, but factoring it using a different technique. Okay, letter C gets us to do something else, which, a difference of squares is another way that I can factor this. So if I take a look at this binomial, it's got two terms. The first term needs to be a perfect square for me to do this, and it is, right? 9's a perfect square, so is x squared. 100 is also a perfect square, and there's a subtraction in between them. So I know I can use the difference of squares pattern, and the way it works is, well, I can take the square root of the first term and take the square root of the last term, and in between them they get different signs. One's a plus, one's a minus again. And if I were to use, distributive property and multiply this out, there will be no middle term there. There won't be an x term. Because when you distribute, you're going to get a negative 30x, but also a positive 30x, and those will simplify to 0 for me. So I know this works. And I've got my two factors, so I can set each of them equal to 0 and solve. So one of them, x is going to be 10 over 3. And the other one will leave me in a place that says x is equal to negative 10 over 3. Okay, so I've got two distinct solutions here. Two x values, two x intercepts, two zeros, whatever you want to call them. Okay. Now, I'm usually not told how to solve one of these quadratic equations. It will basically just say solve, and it'll be up to you to choose the method that you think will work the best, or the one that you prefer. Now, if a quadratic equation can be solved, chances are it can be solved using any of the methods above. Factoring, however, it really is restrictive in the sense that you can only factor things that sum and product rule applies to with integers, okay, with whole numbers. So even though sometimes they may have x-intercepts, if those x-intercepts aren't whole numbers and they are rational numbers, in other words, fractions or decimals, factoring is going to be very difficult, if not impossible, to do in order to solve them. So I can try to look for two numbers here that are going to multiply to negative 5 but add to 7. And if I list out everything that multiplies to 5, well, this is my only combination, right? I can't really do this any other way. And 5 and 1 will never add to 7. So based on the techniques I know, I can't do this right now. But I know that if I graph this, there probably are going to be some solutions here. There will be some x-intercepts. So I can't factor this, but that means there has to be another way for me to do this. And that's where the quadratic formula comes in to help. Now, we're not going to prove where it comes from because it has a couple other things that we don't talk about in this course. That topic is called completing the square, which you can look at in the 20-1 video playlist. I have it in there as well, but in terms of the scope of 20-2, it's just not in there. So we can take this formula, and if our quadratic equation is in this format, and I know the coefficients of a, b, and c, well, this is a nice way for me to compute that value of x without actually having to do any factoring. Okay, so this is my last resort, just because it looks pretty gross. There's a lot of parts to this. Okay, so negative b is the coefficient of your x term, and then you've got a symbol in the middle here that looks like a plus sign and a minus sign combined, and that's exactly what it is, right? It's a plus or minus symbol. So I know I'm going to have two solutions here, and I can write them separately out for you so you can see what I mean. So x is either going to be negative b plus the square root of b squared minus 4ac divided by 2a, or it's going to be x is equal to negative b minus the square root of b squared minus 4ac divided by 2a. So that plus minus just combines them, but if I have to go actually get the values for them, I have to do it separately. One is the positive version, the other is the negative version. That's all that means. So let's go see how this works and see how this will even help us, if it helps us. So we're asked to solve each of the following using this formula, round to the nearest hundredth if needed. So there's two kinds here. One where it says round to the nearest hundredth. The other says leave as an exact value. Now there's 4 of each. We'll do 2 of each kind, and I'll leave the other 2 blank. I won't do them in the video. That way you can try them, and I'll have them in the solution key should you want to see it. So let's take a look at how this was going to work out for us. So I need my polynomial to be in the form ax squared plus bx plus c equals to 0 in order to do this. So if I just write that underneath in blue, you can see that the coefficients tend to match up with their letter. So I know that the value of a here is 1 because that's the coefficient of x squared. The value of b is positive 4, but the value of c here in blue, I'm supposed to have a positive, but in the question I actually have a negative. So c I know has to be negative 1. The signs are going to go with it. Okay, so once you've got all your coefficients there for a, b, and c, Well, now I can use that quadratic formula. So if I write it down here to set this up, x equals negative b plus or minus the square root of b squared minus 4ac, whole thing gets divided by 2 times a. So all those numbers are going to go into their place, right? What I'm going to be left with in the end is that value for x. It'll tell me what the x-intercept or the 0 happens to be. So I really just need those 3 numbers to do this. So x equals negative b. Well, b is 4, so it has to be negative 4 plus or minus the square root. Well, b gets squared minus 4 multiplied with a is 1, c is minus 1, whole thing divided by 2 multiplied with 1. So I've got all of the numbers into where they're supposed to go. Only thing left to do is simplify this and get a value for x. So x equals negative 4 plus or minus square root. Okay. Inside that square root sign, that radicand, there's a lot of pieces happening, so we'll take it slow. 4 squared is 16. We'll leave the minus sign there. Now 4 gets multiplied with 1 to give us 4, but then that gets multiplied with negative 1 to give us negative 4. Divide the whole thing by 2. So if I simplify this, one more time, I'm going to have x is equal to negative 4 plus or minus the square root of 20 divided by 2. And now I'm asked for this in, I think this just froze for a second, so let me just fix this iPad up. Oh, there it goes. It just kicked in. So I'm asked for this to the nearest hundredth. So really I'm going to need a calculator because I can't do the square root of 20 in my head. So remembering that there's going to be 2 possibilities here. One is the plus version, one is the minus version. X equals, well, we'll do negative 4 plus the square root of 20. Okay, and I tend to hit, enter first here to make sure I really get the numerator that I want. And then I have to divide by 2 still. So divide by 2. Nearest hundredth is going to be 2 decimal places. So for this first one, it's 0.24. And if I go do the minus version for the other x value, the second x-intercept, we'll do negative 4 minus the square root of 20. And then divide it by 2. And here's the other possible value, negative 4.24 if I round this. Okay, so 2 values for x here. And in terms of a graph, we can talk about what that looks like as well. Let me just open up, a graph here. So bear with me. If it decides to load for us, there we go. So if I actually go to graph this and I do x squared plus 4x, right? Plus 4x minus 1 equal to 0. Actually, here's what the polynomial will look like. So this is more familiar, the quadratic. So really these x's that we found together are my x-intercepts, those points where it crosses the x-axis. And you can see them right here, right? These are the exact same values that we have. I just rounded them to the nearest hundredth like I was asked, right? 2 decimal places. So that's what these numbers actually represent from that quadratic formula. They represent where your equation will cross that x-axis, okay? The x value of those coordinates. That's what it means. So, we can do this as many times as needed. So the one thing that really needs to happen is it needs to be equal to 0 before I use this formula. Sorry, this iPad's being a little weird. So I have to have it in this format in order to solve this. That way when I set this up with, comparing it to the original generic equation, I can get the letters and the numbers in the order they're supposed to be. So A here is 2, B here is negative 11 this time. Notice the sign, it's negative 11x. C is 13. Okay, so same formula, x is equal to negative b plus or minus the square root, b squared minus 4ac, whole thing divided by 2a. So if I put in negative b this time, well, b is already negative 11, so that will become positive 11. Right, the double negative there will simplify to a positive, so b gets squared. Now it's very important that you put b in brackets here because of that negative. It should also be getting squared, right? The whole b value, not just the 11. minus 4. A is 2, C is 13. Divide this by 2 multiplied with A. Okay, so I'm going to grab a calculator to help out with the part underneath the root sign here, and I'm going to plug it in exactly how I see it, even with the brackets. So negative 11 squared minus 4 multiplied with 2 and then multiplied with 13. Enter. And I get 17 as the number underneath that root sign, which looks excellent. So 11 plus or minus 17 divided by 4. And again, I'm going to have two possible answers here because I can actually square root this 17. Now, if that number underneath was a negative sign and I can't square root it, there's not going to be a solution. There won't be an answer because I can't find one, right? I can't square root a negative. So as long as it's a positive, we're okay. So 11 plus the square root of 17 divide by 4, 3.78, or if we do the negative one, so 11 minus the square root of 17, then divide 4, and 1.72 is the other possibility. So you could graph this in a graphing calculator in Desmos as well, and you will see the exact same number. So I won't do the two underneath. We'll go talk about the exact radical form to wrap this up. Really, there's nothing different except that, you know, we're not going to get a decimal answer. We're going to leave it as a fraction with the root sign. Okay, that's the only change. Okay, so exact radical form is told to us at the top. It's where radicals or root signs in the solution are left as mixed radicals when they can't be simplified. Okay, fractions get reduced to lowest terms. So really it's a way of writing this as an exact answer, not a rounded decimal. Okay, a little different. So again, we'll do A and B, and I'll leave you know, C and D, and you can check them out in the solutions. So again, I'm in the same format I need to be in, so I know that A is going to be 1, B is going to be 7, and C will be 3. So same formula, negative B plus or minus the square root, B squared minus 4AC divided by 2A. So if you throw everything into this, where it's supposed to go, well, x should be equal to negative 7 plus or minus square root of 7 squared minus 4 multiplied with 1 multiplied with 3 over 2 multiplied with 1. And we can simplify as we go here. So negative 7 plus minus square root. Well, 7 squared is 49. I'm going to minus 12 from that. So 49 minus 12, just to make sure we get the right number, 37. Okay, so plus minus 37 divided by 2. Okay. Now, if I think about 37, they're not really any perfect square factors of 37. I know it's a prime number, so right here I'm done. I don't even have to enter in my calculator, nothing. I can't reduce the fraction anyways, because 7 and 2 don't reduce, and the coefficient in front of that radical is a 1, so nothing can be made any smaller into lowest terms. So right here I'm done. Right, really nothing to do here. Okay, we'll try B out as well. It looks a little different. I'm not in the same format. I'm not equal to 0 right now. So I need to make sure I subtract a 7x from both sides of this first. So that 6x squared minus 7x minus 3 is equal to 0. Now I can see that A, B, and C number in the correct, you know, orientation. So I know A is 6 now. B is negative 7. If I did this from the original, it kind of looks like it's positive 7, but I wasn't equal to 0 yet, so I can't do that. So C is actually going to be negative 3 here. So I got everything I need. So x is equal to negative b plus minus square root b squared minus 4ac divide 2a. Same formula once again. So throw in all the numbers. So x equals to negative b. So negative 7 plus or minus the square root of negative 7 squared minus 4 multiplied with 6 multiplied with negative 3 divided by 2 multiplied with 6. Okay. So I got a little bit of a larger number underneath that root sign now. So that's positive 7 plus minus and then our number underneath. So I'm going to grab a calculator here. So we'll do our negative 7 squared minus 4 multiplied with 6 multiplied with negative 3 enter. I get 121 over 12. All right. Now the nice thing here is that 121 is a perfect square number, right? It's 11 squared to get me to 121, right? 11 squared, 121. So I know that I can square root that radicand, no harm, no foul, and I can write this as x is equal to 7 plus or minus 11 over 12. Okay, so in terms of simplified form, that's really as far as I can go, because you know, now 7, 11, and 12 don't share a common number, so I can't reduce this fraction any further. But I know that I can get rid of that root sign. So in terms of a simplified exact answer, this would be it, and I can leave it right there. I don't have to get that decimal. Okay, so there it is, all fully simplified. So I'll leave out again C and D so you can try them. See what you come up with. Check the answer key if you know you get a little stuck. But really, that's the quadratic formula. It allows us one extra way to solve some equations if they can't be factored, right? And if it can't be factored, it's not to say it can't be solved. It just can't be solved using factoring. Okay, and again at the bottom you'll see a few more practice ones. You know, solve it using a graph, which is something we've done previously. Quadratic formula, factoring, and again, you know, at the bottom you'll have the answer key there as well, so you can take a look at that. So there's one lesson left in quadratics when we talk about some of those word problems and applications. So check out the next video. You'll see the link up in the top corner here. And you know, until then, take care. We'll see you next time.